Hi, welcome back. Okay, so in last lecture we talked about how using models could make us more intelligent citizens of the world, how we could just sort of understand how the world works a lot better, how it was sort of the new lingua franca. All right, in this lecture, we're going to talk about how models make us clear thinkers. And this is one of the big reasons why people use models, is because they just help us think more logically about how the world works. Okay, so this is sort of a multi-step process, so let's see exactly how it plays out. So the first thing you do when you write down a model is you name the parts. So let me take a simple example. Suppose I just want to write a model of where people go for lunch. And let's suppose it's a small town and there's really just sort of, 4 restaurants. So there's restaurant 1, restaurant 2, restaurant 3, restaurant 4. So those are parts, right? But what else is parts? Another part is people, right? So there's these individuals and they've got to decide where to go, right? Which restaurant do I go to? Well, now we have to ask, what are the relevant parts of the people? Well, this guy's wearing shoes, but the thing is, his shoes probably aren't a relevant part. So when we name the parts, we're going to think about what really matters. And the shoes probably don't matter, nor does it matter if he's wearing mittens or if we put a hat on him. His hat isn't going to have much of an effect on which restaurant he goes to. Okay, so what does matter? Well, one thing that matters is how much money he's got, right? And how expensive these restaurants are. So this restaurant may be cheap, and this restaurant may be expensive, but this may be someone who's got a lot of money. So how much money you have is going to be one determinant of which restaurant you choose. Another thing that's going to matter is how much time he has. Does he have only 15 minutes, right? Or does he have a whole half hour to go have lunch? And different restaurants may take different amounts of time. A third thing, maybe, and I'll write this fancy little signal here for preferences. This is how economists and social scientists write preferences down. These are just, what he likes. Maybe one of these is a Mexican restaurant. Maybe one of these is an Italian restaurant. So he's going to have different preferences over the different restaurants. So these are all things, these are all sort of relevant parts that go into the model. All right? Once we've laid down the parts, then we've got to think about the relationships between those parts. So models help us sort of identify the specific relationships. So what you see on the left is a simple game theory model. This is called an extensive form game, where one player, here's player 1, makes some sort of decision, and then another player, player 2, takes some sort of decision, and then the players get payoffs. So once you sort of name the parts, then the next thing you do in a model is identify the relationships between those parts and how things play out. So now you've got the parts, you've got the relationships. What you can do is you can think through the logic. So let me show you how complicated this is and how models are so useful. Let's do sort of a simple thing that I sometimes play with my undergraduates. Suppose I want to build a rim for the Earth to be shot through. Build a big basketball, I'm going to shoot the Earth through the rim. But I want to give a little bit of space so you can make it. So I'm going to put 1 meter sort of all the way around, right? So there's a little bit of a gap of 1 meter, and then the Earth can go through with just that little bit of spacing, 1 meter all the way around. Well, now I'm going to ask the question, what should the circumference of that rim be? How big around does that rim have to be, assuming that the Earth is, let's just simplify it, say it's 25,000 miles around the equator of the Earth. How big around does that rim have to be if I want 1 meter of clearance all the way around? Think about it. Okay, well now let's do a little math. So we know the formula for circumference of a circle, right? Circumference is equal to pi times d, right? Now what I want is I want to find the circumference of that rim, and that's going to be pi, but my diameter is going to be the diameter of the Earth. And if I think about it, remember I've got this rim here, and I want the Earth to go through, but I want 1 meter on this side, and I want 1 meter on that side. So it's going to be the diameter of the Earth plus 2 meters. So the circumference of my rim is going to be just pi times the diameter of the Earth plus 2 meters. Well, that's pretty easy to solve, right? Because that's just going to be pi times the diameter of the Earth plus pi times 2 meters. Well, pi times the diameter of the Earth, we already said was 25,000, and pi times 2 meters is just going to be 6.28 meters. So the circumference is going to be 25,000 and 6.28 meters. So that's probably not what most of you guessed, right? So by writing down a very simple model, just a model for the circumference of a circle, we're able to figure out exactly how big that rim has to be, and it's often very different, right, from what our intuition would have suggested. Okay, so working through the logic is a big reason why models make us clear thinkers. Now the next thing models do is they allow us to inductively explore. And so let me give a sort of a fun example of this. Suppose you have a room, right? And we've got this room here, and there's a door. There's one little door right here that people can come out of. And the problem is jammed in the door, right? So, it was people trying to exit this room, everybody gets jammed in the doorway. So it's a question of how do you figure out a better way to prevent people from getting jammed. But one thing you might do is you might put a post right here, and this post might prevent people from bumping into each other as they come out, because they come in here, they sort of bump into the post, and they have to go around, and that prevents people from sort of getting bunched up near the door. So what's interesting here is once you construct a model of the room, when you put a bunch of people in the room, right, so here's people, and then you have them run out, you can ask, what's the effect going to be of putting the post in? You can inductively explore better ways to sort of position things in the room to prevent people from getting piled up. Okay? Now, once we've sort of worked through the logic and explored things, we can ask, what exactly happens in our model? Now, remember when we talked about types of outcomes earlier on? I said there's really 4 things that can happen in a model. One is it can go to some sort of nice equilibrium, like the planets, if I drop my pen, it just rests on the floor in equilibrium. It can go in some sort of cycle, right, like the planets orbiting the sun. It can be completely random, right? It can just be, totally unpredictable and random. Or it can be complex. And so one thing that models like it let us do is figure out which of those things is going to happen. So let me throw something out there. Suppose we're looking at oil, which is a commodity, right? And we want to ask, what about the price of oil? What about the demand for oil? What can we say about those things? Well, let's think about it. The demand for oil is, probably going to depend on the size of the economy. And so therefore you'd expect, since the economy tends to grow at a fairly constant rate, you'd expect, the demand for oil, the total supply of oil, to probably slope up, right? What about the price of oil? Well, the price of oil depends on a whole bunch of people who are sort of they might have some in reserve, and they're bargaining, and they're buying and selling, and all sorts of crazy stuff can go on. So if I were going to make a guess, I would say, that the supply of oil is some sort of nice pattern, right? The total world demand and supply of oil is probably a nice pattern. But if I look at the price of oil, it's probably crazy, okay? And so, in fact, if you look at it, that's exactly what you see. So here's oil production right here, and that satisfies sort of this nice upward slope. But if you look at the price of oil, which is down here, that's just crazy. It's completely unpredictable. It's what we'd call complex. It's not random, right? But it's complex. So the models, but if you construct models of these two things, we can see why, total production of oil goes up and why the price of oil is so hard to understand. Okay. Next, identify logical boundaries. This is one of my favorites. So there's a website called Opposite Proverbs. And on this website, you see statements like these too. 2 heads are better than 1, and that's certainly true. Often it's the case that 2 heads are better than 1. And too many cooks spoil the broth, and that's often true as well, right? It is true that too many cooks do spoil the broth. Well, here's the problem. Theirs are the opposite, right? The same is with a stiction time saves 9, and he who hesitates is lost. So if you just have these sort of proverbs or mantras that you sort of follow, they're not going to do any good, because there's always going to be an opposite proverb that says do the opposite thing. So which one do you follow? What models enable us to do is find the conditions under which one thing holds and one thing doesn't. So later in this course, we're going to see when is it exactly the case that 2 heads are better than 1, and when is it exactly the case that too many cooks spoil the broth. So even though these proverbs are opposite, there's conditions under which one each holds. All right? Okay. Last thing, communicate. One of the real beauties of models is they allow us to communicate our ideas and what we know really simply. So let's take politics, for instance. And suppose you want to ask me, Scott, how do people vote exactly? Now, I could say, well, it's pretty complicated. I think that people, they like candidates or they don't like candidates, and then there's these things called issues, and there's a question of is the candidate, do they take positions on issues that you like, or do they don't take positions on it you like, and they balance these things, and they watch debates, and I could go on and on and on and on, and you might have really no idea when I'm done how I think people vote. Well, let's suppose instead I write down a really simple model, and I say, okay, so here's how it works. There's going to be a voter, and there's going to be 2 candidates. So here's my voter, and here's candidate 1, and here's candidate 2. Now, what the voter does for each of these candidates is they've got some sort of likability. So they can say sort of there's likability of candidate 1 and there's likability of candidate 2. And this is just sort of like, how friendly do they seem? Do they seem trustworthy? Do they seem honest? That sort of stuff. So this is, we'll put likability here. Now the second thing I'm going to say is that people care about policy. Now for policy, what they care about is sort of this set of issues. So you can think of, on policies, what I'm going to do is I'm going to say that the voter, I'm going to put a little left-right continuum to say the voter over here is maybe a little bit conservative, right? And then for these candidates, I'm going to say, well, candidate 1 is over here, is kind of liberal, and candidate 2 is really conservative, right over here. So this is where candidate 2 is. So now, here's my model of how people vote. What they do is they sort of say, okay, well, how likable is each candidate? Right? So they look at the likability of candidate 1 and the likability of candidate 2. And then they ask, how far apart is, here's my sort of policies, you know, I'm maybe a little bit to the right. How close are these candidates to me? Well, candidate 1 is pretty far away. Candidate 2 is a little bit closer. So then, how people vote depends on the combination of these two things, likability and how close somebody is in policy space. Notice how that's a much clearer way of explaining exactly how I think, and it enables me to communicate much more clearly to other people, how is it that I vote? Okay? All right, so that's how models make us clearer thinkers. Now, what we're going to do next, once we've sort of got this understanding of models helping us think logically, is we could take those logical models and bring them to data. Thank you.